So again, there's a Quizlet in the, I can put the link right on the module, but if you go to the home page because you want to join the class, there's the link to the class, and then you can practice that Quizlet as many times as you want to. And it's got all the formulas and all the, like, the restrictions for your inverse. I try to put as much in there as would make sense. Obviously, the graphs are, besides, like, I gave you the parent functions of the inverse ones. When you are finding, so if you're looking at your quizzes, if you're finding the domain and range, okay, so after we put the equation into its inverse, this is one of them. Actually, don't need that one. Okay. You got an equation that looks like that, right? So like the finding the equation, everybody did a good job at getting. Okay, it was the then finding the domain and range that was a struggle. What is the domain and range of the cosine -1 function? Domain is -1 to 1 and range 0 to pi. So the 1/3 on the front affects what? That's your range. It's a vertical dilation by a factor of 1/3, which means I'm going to alter the range with that. Yep. So it would be 0 to pi over 3 for your range. Then you've got the 3 inside, right, next to the cosine, and that does what? This would be a horizontal dilation, right? By 1/3, which means I'm going to multiply my domain by 1/3. So I get -1/3 and 1/3. Then next to that is your x plus 1 inside the parentheses affects what? Domain, because it's a horizontal shift. In which direction? Left 1. So if I'm going left, I'm going to move these left. So -1 and -1/3. And then -1 minus 1/3 would be -2/3. Yeah, remember, stretch before you move. Stretch or shrink before you move. Questions on that? Because again, that's like a question that's got multiple parts. It's got the find it, and then it's got the domain and range. So it's almost exactly like number 10. Okay, just to clarify, I said it yesterday, and I'll say it again. You will get 3 of these types of graphs. I gave you one of each. You are either going to get the cosine or the sine. You are either going to get the cotangent or the tangent. And then you are either going to get the secant or the cosecant. At the top on the first page, those are the things I'm going to ask for on your test. So for sine and cosine, it's going to ask for amplitude, period, the key points, describe the transformations, and the graph the 2 periods. For tangent, cotangent, secant, and cosecant, it's going to ask for the period, the asymptotes, the domain and range, and then obviously the graph. I put it there, but I want at minimum 3 asymptotes and 2 curves. For some of them, you get a lot more than that, but for those at least minimum, that's what you should see. Here we go. All right, I'm going to go over a couple of these questions. So starting with number 5, it says 3 = 1 minus 2 cosine 2x. So this is one of the multiple angle ones. So I'm going to solve for that 2x, and then I'm going to adjust the angle and the interval at the end. So I'm going to subtract the 1. 2 equals -2 cosine 2x. Divide by -2. And I get -1 equals cosine 2x. So now I need to find where my circle cosine is -1 and cosine is -1 at pi plus 2n pi. And then there's no interval. So that's one of the reasons why we add that on there, but also because 2x equals that. So now I divide everything by 2, and I get x equals pi over 2 plus n pi. And that's the solution. Number 6 says 4 sine 2 theta minus 1 equals 2. And then you're going to add the 1. 4 sine squared theta equals 3. Divide by 4. Sine squared theta equals 3 over 4. To get rid of the squared, we're going to square root, but you got to put a plus and minus in the front. So I'm going to get sine of theta equals plus and minus square root 3 over square root 4, which is 2. So now I'm looking for plus my interval, so plus 2 and pi. But I'm looking for wherever my, right, sorry, I'm just checking. No, yeah, it doesn't give you the interval. So I'm going to add on the 2 and pi at the end. But I'm looking for wherever the sign is root 3 over 2, which happens at all the over 3's. So pi over 3 plus 2n pi, 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. All right, under that, we're going to do this question, 3 cosine squared x minus 7 cosine x plus 2. As soon as you see that you've got the cosine squared and the cosine, that's your hint, you're going to have to factor this. So if you want to substitute in, like you can make a your cosine, and I can say 3a squared minus 7a plus 2 equals 0. And then we multiply first times last. 3 times 2 is 6. Factors of positive 6 that sum to negative 7 would be negative 1 and negative 6. Plug those back in place of this negative 7a, so negative 1a, negative 6a plus 2, and then factor by grouping. So you take out an a, and you get 3a minus 1. Take out a negative 2, and you get 3a minus 1. 3a minus 1 times a minus 2. A equals 1/3, and a equals 2. And I just realized these were supposed to be cosecants. This was cosecant. So now it's the cosecant equals 1/3 and the cosecant equals 2, which means the sine equals 3 and the sine equals 1/2. There is nowhere where sine equals 3 because it can't be bigger than 1, so we ignore that one. But then we want to locate where sine is 1/2, which happens at the over 6. So pi over 6 and 5 pi over 6. And to each of these, we're going to add on the interval 2n pi. Okay, now I'm going to do the tangent one. So tan x over 2 equals negative root 3. And as it is a multiple angle, so at the end I'm going to adjust it. But for now, there's nothing to solve. I'm just looking for where tangent's negative root 3. And it would be at 2 pi over 3 plus n pi. Remember, for tangent, if you don't have the interval, you're just using the top and you're adding on the n pi. And then we multiply by 2. So I get x equals 4 pi over 3 plus 2n pi. Okay, on this page, I'm going to work out this guy first. So sine squared theta cosine theta plus cosine to the third theta equals 0. And it says solve in the interval of 0 to 2 pi. We're going to include 0, but not include 2 pi. So because cosine is there twice, I'm going to factor it out. I'm going to take out only cosine to the first. Can I take out? And I get sine squared theta plus cosine squared theta. And if I was just verifying this or I was simplifying this, this would actually become 1. But because we're solving this, you can't eliminate the trig functions. So we're going to keep those there. And we're going to split and solve. So we say cosine of theta equals 0. And then sine squared theta would equal negative cosine squared theta. So now I'm looking for where cosine is 0 and the x is 0 at pi over 2 and 3 pi over 2. And then this one's a little weird, but you're looking for where your sine and your cosine have the same value, but different signs, which happens at 3 pi over 4, where it's negative root 2 over 2 and positive root 2 over 2, and 7 pi over 4, where it's again negative root 2 over 2, or positive root 2 over 2 and negative root 2 over 2 that time. So those are your 4 solutions for that one. Okay, then we're going to work out the sum and difference. So sum and difference, the first one says sine of 5 pi over 3 minus pi over 4. This is your sine difference. And the pattern is sine, cosine, cosine, sine. So sine 5 pi over 3, cosine pi over 4, minus, because we keep the sine, cosine 5 pi over 3 times sine pi over 4. And then our angle 5 pi over 3 is in the third quadrant. It's 1/2 and negative root 3 over 2. And our angle pi over 4 is in this first quadrant, root 2 over 2 and root 2 over 2. Sine at 5 pi over 3 is negative root 3 over 2. Cosine at pi over 4 is root 2 over 2. Minus cosine at 5 pi over 3 is 1/2. And sine at pi over 4 is root 2 over 2. So I get negative root 6 over 4 minus root 2 over 4. And I get negative root 6 minus root 2 all over 4. Now I'll do the cosine one. So cosine, same angle as 5 pi over 3 plus pi over 4. Cosine's pattern is cosine, cosine, sine, sine, and we switch the sign. So cosine 5 pi over 3, cosine pi over 4, minus sine 5 pi over 3, sine pi over 4. Same angle as we already used. The cosine at that angle is a positive 1/2. Cosine at pi over 4 is root 2 over 2. Minus the sine at 5 pi over 3 was negative root 3 over 2. And the sine root 2 over 2. And I get root 2 minus a negative, so it becomes plus root 6 all over 4.